Okay, ladies and gentlemen, we're going to talk a little bit more about some angles, and particularly angle relationships. We've already talked about acute, right, obtuse, and straight angles. Now let's talk about how those angles might interact. Let's do a couple things very quickly. If I draw a line here, I'm going to call it L1 because, of course, what do we always do anytime we put anything on a picture? We label it. Let's also do another line over here. We're going to call this one line 2. Okay. Now, having line 1 and line 2, let's label this point here in the middle. Let's call it A. Throw some labels on here. B, C, D, E. Okay. So we have a number of labels that we can work with. First thing we're talking about is adjacent. Ladies and gentlemen, if I am sitting adjacent to you, that would mean I'm sitting right beside you. So anytime we're talking about angles that are adjacent, we're talking about angles that are right beside one another. So in this case, EAB is adjacent to BAC. The way we can tell that angles are adjacent is if they share a side. So in this case, angle BA is shared between EAB and between angle BAC. This is a shared side, therefore making it adjacent. Now, by being adjacent, they are next to each other. That is all that can be said for them. Nothing else at this point. Now, what we can do is, because I did create all these angles, by the way, how many angles do you see? 4. 4 angles, 1, 2, 3, 4. And these angles, because this was a straight line, when I crossed the other line, I created this angle and this angle. But since they were a straight line to begin with, these two angles form a linear pair. And of course, you know, because it says the word line in it. A linear pair is a pair of angles that are adjacent and make a straight line. So they have to be adjacent and make line. Okay. Now, by the way, a linear pair, of course, will add up to how many degrees? 180, because you just made a straight line. So linear pair makes 180 degrees straight line. These two are a linear pair. Interestingly enough, though, remember this was a straight line, so these two are a linear pair. Well, just like these two were a linear pair on this side, so these two are on this side. So the idea of a linear pair becomes important because now it gives us a number that we can attach to some of these angles, and that's going to become exceedingly important as we move forward. Now, let's go to a vertical angle. Now, vertical traditionally means up and down. But if I were looking for vertical angles in this section here, I would say that my prime vertical angles would be right here and right here. Those are vertical angles because it's not the up and down that matters. It's the vertex angles formed by lines that are across a vertex. So two lines cross. The vertical angles are formed across the vertex of that line. By the way, yes, indeed, this angle and this angle are also vertical angles. So you have one set of vertical angles, two sets of vertical angles. But we start here because I don't want you to get confused with the up and down component. Now, whereas linear pair add to 180, vertical angles are congruent. Vertical angles are going to have the same measure. We'll talk about that momentarily. Now, complementary angles. Complementary angles at two angles add to 90 degrees versus supplementary angles that add up to 180. So supplementary angles are angles that add to 180. Now, in our case, we don't have any right angles, so I can't work with complementary, but I certainly can work with supplementary. This angle here, remember, and this angle here used to make a straight line. That would have been 180, so these two together make 180 and therefore are supplementary. So linear pairs are always supplementary. But supplementary angles are not always linear pairs, because one of the things we could do with a supplementary angle is if I have a 60-degree angle over here, and I have over here facing in an entirely different direction, 120 degrees, these two angles are supplementary, but they are not a linear pair because they are not adjacent to one another. So supplementary, but not a linear pair. These are a linear pair and supplementary. Now, that brings us to perpendicular. Well, perpendicular means two angles, or an angle that is 90 degrees formed between two lines. So two lines that form a 90-degree angle are called perpendicular. Now, this is where we can come up with our complementary, because let's say I put another side in here. If this was 90 degrees to begin with, and I split it up, that means this angle here and this angle here would add up to 90 degrees and therefore be complementary. One of the ways that we really put this to work is if I give you the following: 2x and x plus 7. That means that these two are what kind of angles? Vertical angles. So vertical angles must be congruent. So if I'm going to use vertical angles, I can say that 2x has to equal x plus 7. And now I can solve that for example number 1. On the other hand, let's look at example number 2. I have these two lines. And I have, this is 3x minus 1, and this is 4x plus 4. And in this case, actually, let's go 4x plus 9. All right. And these two angles, this one plus this one, are a linear pair, making it therefore 180 degrees. So I would set up 3x minus 1 plus 4x plus 9 equals 180 and begin to solve that. Now, if I have this and I cut that angle with another one, and I have 2x plus 5 and I have x minus 5, well, for this angle and this angle, what must be true about those two? Well, I should be able to put those into an equation. For example, 3, because 90, not 9, because those are complementary. So the idea of complementary, supplementary, perpendicular, vertical, linear, all have to be put together. Now, the last one is example 4. And in this case, all I'm giving you is 70 degrees. You need to find angle 1, angle 2, angle 3. So find angle 1, comma, angle 2, comma, angle 3. And give reasons. Of course, none of this matters unless you give reasons for all of your solving.